45 years ago, a machine the size of a small car left Earth carrying a golden record meant for alien ears, and right now, billions of miles away, that same machine is sending back a signal that has scientists genuinely stumped. Not a glitch, not a malfunction, but a real physical anomaly at the very edge of everything we understand about our solar system. Voyager 1 is drifting through a region of space no human instrument was ever designed to survive this long in, and the data it just beamed home does not match a single model scientists built before it got there. Stick with me, because by the end of this, you're going to understand why some of the top space physicists on the planet are openly saying, quote, "We know now how little we know about the heliosphere." Let's set the scene properly, because the scale here is almost impossible to picture. Voyager 1 and its twin Voyager 2 launched back in 1977, riding a rare planetary alignment that only happens once every 176 years, which let them swing past Jupiter, Saturn, Uranus, and Neptune, using the gravity of each planet as a slingshot toward the next. Along the way, they rewrote entire textbooks, discovering that Jupiter's moon, Io, was an active volcanic nightmare rather than a dead gray rock, mapping the thick nitrogen atmosphere on Saturn's moon, Titan, and becoming the only spacecraft in Neptune where they found screaming supersonic winds, more than a dozen new moons, and Uranus's bizarre, tilted magnetic field that still puzzles scientists today. By 1989, their main planetary mission was technically finished. NASA could have shut them down right there. Instead, engineers made the call to keep them running, and that decision is the reason we are talking about them again today, decades later, at the very edge of the solar system. Here is where the real story begins. In 2004, Voyager 1 crossed something called the termination shock, the point roughly 8 billion miles from the Sun, where the constant outward blast of solar wind suddenly slams into the pressure of interstellar space and abruptly slows down. Voyager 2 crossed that same boundary in 2007. Beyond that lies a turbulent transition zone called the heliosheath, and beyond that lies the heliopause, the outer edge of the Sun's bubble of influence, where the pressure of our star's solar wind finally gets matched and stopped by the pressure of the interstellar medium. Voyager 1 broke through that boundary in 2012, and Voyager 2 followed in 2018, making them the only two human-made objects ever confirmed to leave the protective bubble our Sun creates around the entire solar system. Beyond that boundary is something scientists call true interstellar space, a completely different environment made of ancient dust from long-dead stars and energetic particles called galactic cosmic rays that have been drifting through the galaxy since long before Earth existed. And this is exactly where things stopped making sense. Scientists went into this expecting a clean, simple transition, the Sun's magnetic field on one side, the totally different magnetic field of interstellar space on the other, like flipping a switch. That is not what happened. Instead, in 2020, Voyager 1 flew directly into something researchers now call a pressure front, a sudden and completely unexplained spike in the strength of the magnetic field surrounding the spacecraft. Nobody predicted it. Nobody has fully explained it since. Even stranger, when Voyager actually crossed what scientists believed was the true heliopause boundary, the direction of the magnetic field barely changed at all, which flew in the face of everything researchers thought they understood about where the Sun's influence physically ends and where deep interstellar space physically begins. A team of researchers eventually proposed an explanation, and it is a genuinely wild one. Instead of the heliopause being a thin, sharp boundary line the way scientists pictured it for decades, similar to a soap bubble with a clean edge, the new theory suggests it is actually a thick, complicated transition layer formed where the Sun's magnetic field and the interstellar medium's magnetic field tangle together and interact over a much broader region than anyone expected. If that theory holds up, it means Voyager 1 technically has not even reached what scientists would consider truly pristine, undiluted interstellar space, yet despite having already traveled more than 8 years beyond where researchers thought that boundary was. Let that sink in for a second. We built a spacecraft, watched it travel for nearly half a century, confirmed it left the solar system entirely, and it might still be sitting inside some kind of murky in-between zone that current physics cannot fully define. Merav Ofer, a space physicist at Boston University who has spent years studying this exact region, put it about as bluntly as a scientist ever does in public. She said the heliosphere is way more complex and way more dynamic than researchers ever thought. Jamie Rankin, deputy project scientist on the Voyager mission at Princeton, has pointed out something equally important, that literally every single measurement of deep space made by any instrument before the Voyagers crossed this boundary was filtered through multiple layers of the Sun's own influence. In other words, humanity's entire prior understanding of what lies beyond our solar system was built on second-hand, indirect evidence. The Voyagers are the very first instruments to physically sit inside that environment and report back what it is actually like, and what they are reporting does not match the models. There is another layer to this mystery that almost nobody outside of specialist circles knows about. In 2008, NASA launched a separate spacecraft called the Interstellar Boundary Explorer, or IBEX, which orbits Earth, and detects particles streaming in from the very edge of the heliosphere. IBEX discovered something scientists still cannot fully explain. A massive, glowing ribbon of energetic particles stretched across the outer heliosheath, visible in IBEX data, but never directly touched by either Voyager spacecraft, because by sheer cosmic coincidence, both probes happened to fly right past it on opposite sides. David McComas, the physicist who leads the IBEX mission, described it in a way that should give you chills. He said that right between the TWO Voyager spacecraft sits the biggest, most glaring unexplained feature in the entire outer heliosphere, and neither probe ever got close enough to study it directly. That single detail exposes just how limited our picture actually is. Scientists have compared the Voyagers to medical biopsies, tiny needle-thin samples taken from two single points in an object that is actually enormous and three-dimensional. Nobody currently knows the true shape of our solar system's protective bubble. Some models suggest it resembles a comet, with a long streaming tail trailing behind a compact, rounded nose punching through interstellar space. Other researchers propose a croissant shape, with two curved lobes stretched outward by the interaction between the sun's magnetic field and the surrounding interstellar medium. Some physicists openly admit the true shape might be something nobody has even theorized yet, because we are trying to map the walls of an enormous bubble from a couple of single, isolated points deep inside it, using instruments built in the 1970s that were never designed for this kind of physics in the first place. And the spacecraft themselves are running out of time to answer any of it. Voyager 1 and Voyager 2 are both powered by decaying nuclear fuel that has been steadily weakening for nearly 5 decades, which means engineers have had to make increasingly difficult choices about which instruments to keep alive. Earlier this year, NASA formally shut down a 49-year-old instrument on Voyager 1 called the Low Energy Charged Particles Experiment, specifically to conserve enough power to keep the spacecraft transmitting data at all. Engineers tested a similar power-saving maneuver on Voyager 2 first, since it has slightly more power reserves remaining, before cautiously applying the same fix to its aging twin. There is even a small chance that instrument could eventually be switched back on if the power situation stabilizes, but nobody is treating that as a guarantee. Voyager 1 has also suffered serious communication problems in recent years, including one incident where engineers briefly lost its exact orientation toward Earth entirely. And any single new malfunction at this point could realistically end the mission for good, with essentially no warning. There's also a strange, almost poetic milestone coming up fast. This coming November, Voyager 1 will cross what scientists call the one light day distance, meaning it will be so unbelievably far from Earth that a radio signal traveling at the literal speed of light will take a full 24 hours just to reach it, and another full day to send anything back. At that point, Voyager 1 will be sitting roughly 26 billion kilometers from home, a distance so vast it stops feeling dreary like astronomy and starts feeling like science fiction, except every bit of it is real, measured, and happening right now. So where does this actually leave us? We have two aging, nearly 50-year-old machines, both operating on fumes, both physically further from Earth than any human-made object in history, and both still sending back data that keeps overturning decades of careful scientific modeling. NASA does have a newer, more advanced probe called IMAP, the Interstellar Mapping and Acceleration Probe, designed to build a much sharper picture of the same boundary region from a stable point NT near Earth. And there is a separate spacecraft called New Horizons, famous for its 2015 flyby of Pluto, that is also slowly heading toward this same interstellar frontier, and could reach it within the next decade if its instruments hold up that long. But for IT now, in this exact moment, the only two working instruments humanity has ever placed beyond the edge of our solar system are two machines built with technology from before most of your grandparents owned a color television, and they are still the only reason we know this mystery even exists at all. If you want more deep dives like this the moment new deep space data actually breaks, go ahead and hit like and subscribe, because we will be tracking every new signal these two aging explorers send back for as long as they keep transmitting. The uncomfortable truth scientists are sitting with right now is this. We spent decades assuming the edge of our solar system would look like a clean, simple line on a map, a tidy boundary where our sun's influence stops and the rest of the galaxy begins. What Voyager 1 and Voyager 2 actually found instead is a blurred, tangled, unpredictable transition. Zone that behaves nothing like the models predicted, filled with unexplained pressure spikes, magnetic fields that refuse to shift the way they should, and a massive unexplained ribbon of particles that both spacecraft somehow managed to miss entirely. It gets even stranger when you look at how the two spacecraft behaved on their way out. One of the Voyagers did not cross the Termination shock cleanly just once, the way engineers originally expected. It actually crossed back and forth over that same boundary 5 separate times before Finn ally pushing through for good. Most likely because the entire heliosphere itself was physically expanding and contracting in rhythm with the sun's own activity, breathing in and out like a living thing on a scale of billions of miles. That single detail alone forced scientists to throw out the simple static picture of the solar system's edge that had been taught in textbooks for generations, and replace it with something closer to a slow, pulsing, ever-shifting boundary that changes shape depending on what the sun happens to be doing at any given moment during its 11-year activity cycle. And even now, years past that boundary, both spacecraft are still picking up faint traces of our own sun's influence bleeding out into what is supposed to be pure interstellar space, which raises an even bigger question researchers have not answered yet. How far does our star's reach actually extend before it truly, completely fades into nothing? Every answer these two aging machines send back seems to open up two new questions behind it, and that pattern has held steady for over a decade now, ever since Voyager 1 first crossed into the unknown back in 2012. Scientists are not just sitting around waiting either. There is a proposed mission called Interstellar Probe that was specifically designed to solve exactly this kind of puzzle, using a massive rocket to punch through the heliosphere far faster than the Voyagers ever could, carrying instruments built specifically to study plasma and magnetic fields rather than repurposed planetary cameras. That mission was ultimately left out of the most recent major funding priorities set for American space science over the coming decade, which means for now, humanity's only real window into this region remains two machines that have already outlived every original expectation anyone had for them, sending back one last generation of irreplaceable data before their nuclear hearts finally run dry. Two machines built in the 1970s, running on dying nuclear batteries, are still the only reason we know any of this at all, and every single day they keep transmitting as another day. Scientists get a few more breadcrumbs from a place nothing else in human history has ever physically reached. When they finally go silent for good, and that day is coming soon, whatever they have not told us yet may stay a mystery for a very, very long time.